Building a drone from scratch is a rewarding and educational project for anyone interested in technology, engineering, or aviation. Whether you want to build a drone for photography, racing, or simply as a hobby, this process will provide you with hands-on experience in electronics, mechanics, and programming. Below is a comprehensive guide on how to build a basic quadcopter drone, explaining the important steps and things to keep in mind throughout the process. Before starting, it is important to understand the basic components that make up a drone. Essentially, a drone consists of a frame, motors, electronic speed controllers, ESC, propellers, a flight controller, a battery, a transmitter and receiver, and optionally a camera. Each part plays an important role in ensuring stability and flight performance. To get started, you first need to choose a frame. The frame is the backbone of the drone and determines the size, weight, as well as the configuration of all the other components. Frames are usually made from lightweight and durable materials such as carbon fiber or aluminum. For most hobbyists, the quadcopter frame, which has 4 arms extending from the center, is a common starting point. These arms support the motors and propellers, while the center houses the remaining electronics. Next, let's consider the motors. Drones use brushless DC motors because of their efficiency, power, and reliability. These motors are what spin the propellers to generate lift. When choosing a motor, pay close attention to both the size and the kV rating, which measures the number of revolutions per minute per volt supplied. The appropriate motor for your drone will depend on the expected total weight and the desired performance characteristics. Along with the motor, you will need an electronic speed controller, or ESC. The ESC is an electronic circuit that regulates the speed and rotation direction of a brushless motor. Each motor requires its own ESC. When choosing an ESC, make sure it can handle the maximum current your motor will draw, plus a margin for safety. The propellers attached to each motor come in various sizes and angles of inclination. Typically, larger propellers generate more lift but require more power, while smaller propellers offer greater agility and faster response times. The right propeller is a balance between the drone's weight and the motor's output power. The heart of your flight system is the flight controller. This small computer continuously monitors input signals from sensors such as gyroscopes and accelerometers, while making real-time adjustments to keep the drone stable. Popular flight controllers like Pixhawk or Betaflight boards also provide integrated support for GPS, drone cameras, and various data transmission systems. The flight controller is programmed with embedded software tailored to the hardware you choose and can be calibrated via a computer or mobile app. With the main electronic components identified, let's talk about the power source. Most recreational drones use lithium polymer, or LiPo, batteries, which provide high energy density and high discharge rates. The voltage and battery capacity should match your motor and expected flight time. Be careful about safety when handling LiPo batteries, as improper charging or physical damage can cause fires or explosions. To control your drone, you will need a radio transmitter and receiver. The transmitter is the remote control you use on the ground, while the receiver, mounted on your drone, sends control commands to the flight controller. Most modern transmitters operate on the 2.4 GHz band and provide reliable, low-latency connections. Although higher-end models support features such as data transmission, feedback, and multi-channel configuration, once you have all the components, the assembly process begins by attaching the motors to the drone frame. Secure each motor with screws at the end of each arm, ensuring the orientation and wiring match the flight controller's requirements. Next, attach the ESC to each arm and connect the three-phase wires to each motor. Pay attention to the wire order. If a motor spins in the wrong direction during testing, simply swap any two wires. Install the flight controller in the center of the frame, using vibration damping materials to ensure accurate sensor readings. Connect the ESC signal wires to the appropriate pins on the flight controller, usually color-coded or referenced in the hardware manual. Additionally, connect the battery power wires to the power distribution board or directly to the ESC, paying attention to the correct polarity. At this time, you can attach the propellers, but only after thoroughly inspecting and double-checking all connections. Each motor comes with a specific type of propeller, rotating clockwise, CW, or counterclockwise, CW. Installing propellers in the correct direction is crucial to ensure stability and lift. After completing the physical assembly, the next step is to configure the flight controller. Connect the flight controller to your computer, install the recommended software, and update the firmware if necessary. Next, calibrate the sensors. The accelerometer should be calibrated on a flat surface, while the gyroscope will calibrate. For advanced builds, you can also calibrate the GPS or barometric pressure sensor. Link your radio transmitter to the receiver on the drone, according to the manufacturer's instructions. Set up the radio channels corresponding to throttle, pitch, yaw, and roll controls, as well as the activation/deactivation switches and flight modes. Before the first flight, check the system. Power on your drone without attaching the propellers and confirm the motor rotation direction. Gradually increase the throttle and ensure all motors respond evenly. Confirm that the radio controller is properly controlling the drone by referring to the live data in your flight control software. When all checks are complete, attach the first propellers, take your drone to a safe, spacious area, and prepare for a test flight. Start by powering on the drone and slowly increasing the throttle. The drone should take off smoothly and hover when the controls are centered. So, try basic movements: forward, backward, left, right, yaw, and altitude changes. Pay attention to stability and responsiveness. If the drone shakes or drifts, land and recalibrate as needed, making small adjustments in the flight control software. After confirming the flight is stable, you can add additional features such as a GPS module for autopilot functionality, a camera for aerial photography, or a data transmission system to display battery voltage and flight data in real time. Throughout the process, prioritize safety. Always build and fly according to local regulations and never operate a drone near crowds, airports, or sensitive infrastructure. In summary, building a drone involves selecting and assembling the appropriate components, programming, and calibrating the system while ensuring everything operates safely and reliably. Each flight is a testament to your technical skills and creativity. As you gain experience, you will be able to customize your drone to increase speed, durability, stability, or perform special tasks. Make the sky truly the limit for your new airplane.